SAIFE is a patented security platform that provides trusted routing over untrusted networks for any IP-based endpoint. SAIFE uses a secure, distributed global network known as TIPRNet to create secure tunnels for SAIFE-enabled devices. SAIFE's continuum servers within the network authenticate devices before allowing connection, and all traffic is encrypted from end to end. To reliably ensure the identity of each SAIFE-enabled endpoint, SAIFE utilizes a trust chain modeled on the best practices of public key infrastructures. But whereas traditional PKIs rely on third parties or other intermediaries to validate and revoke endpoints, SAIFE's authentication occurs completely inside the system, only permitting connections between specified, trusted SAIFE-enabled endpoints. SAIFE's trust chain is ultimately tied to its certificate authority, which is stored in a secured facility and always kept offline. To create a new network node, the CA validates and signs a public certificate for the SAIFE Management Console and the public certificates for each of the continuum servers. The SAIFE Management Console is given elevated permissions in order to sign certificates for endpoints. The continuum servers maintain the real-time list of valid public certificates for all endpoints as well as the revocation list. To add an individual device to the new network node, the device is first added to the SAIFE Management Console. The device uses a deterministic random bit generator to generate a unique public-private key pair along with a self-signed certificate and a certificate signing request. The public key can be used by a trusted second device to encrypt data intended for the first device. The private key of the first device is used to decrypt that data. Because only the private key can decrypt messages encrypted with the corresponding public key, it is stored securely on the device and never revealed. The device sends its self-signed certificate and a certificate signing request to the SAIFE Management Console for validation. A seed key, which is a one-time pad proving the identity of the device, may be used to encrypt the certificate signing request. The SAIFE Management Console validates and signs the certificate. The device is now considered to be trusted. Finally, the device downloads the signed public certificate along with initial configuration data. If the device becomes lost or compromised or needs to be repurposed, it can be quickly revoked through the SAIFE Management Console. The device will be blocked from all actions, and if possible, the data on the device will be erased. To encrypt and decrypt data between devices, SAIFE uses elliptic curve cryptography, which derives its security from the computational complexity of the elliptic curve discrete logarithm problem. To encrypt data, the sending device performs a mathematical operation using the clear text data created on the device, the public key of the receiving device, the agreed-upon starting point on the elliptic curve, and a random integer. The result is a pseudo-random number that would be indecipherable if intercepted by an unintended recipient. The mathematical operation determines the initial direction from the starting point on the elliptic curve and the number of moves between points on the curve. The pseudo-random number is sent to the receiving device, which performs a separate mathematical operation using the pseudo-random number and its private key. The result is the original clear text data. Even knowing the starting point and ending points on the curve, and not the path between, it is extremely improbable in the mathematical sense to determine the private key of either device.